Our last video on our notes for today is leading us into something called the normal model. We're just going to introduce the normal model today, and we're going to learn more about it in our next day of notes. So data that is roughly symmetric can usually be modeled by what's called the normal model. The normal model, and you may have learned about this last year in Math 3, we're doing a little more with it this year. The normal model is based always on the data's mean and standard deviation. One special characteristic is that nearly all of the data will fall within 3 standard deviations of the mean. That's a true statement for the normal model. So as you can see a histogram drawn here, you see your bars, it's a symmetric histogram, and you can see the bell curve, which is another name for the normal model, fits well right over that histogram. So half the data is above the mean and half the data is below the mean. So the mean is going to be somewhere right smack dab in the middle, and half the data is above it and half the data is below it. All normal models have that characteristics. All normal models are centered at the mean. So the peak, the middle, is at the mean. We typically mark off the bottom axis with 3 standard deviations in each direction from the mean. So just like we did earlier when we were looking at how unusual a height was. All right, so let's look at an example. Girls' heights follow a normal model with a mean of 65 inches, so that goes right smack dab in the middle. We can label our graph so we know what we're looking at. And a standard deviation of 3 inches. So every one of these little marks should represent 1 standard deviation. So it's kind of like this is your ruler. This is what you're going by, or your scale. So I'm going to put the mean in the middle, and then I'm going to go by 3s. So this is going to be 68, add 3, 71, add 3, 74, subtract 3, 62, subtract 3, 59, subtract 3, 56. So each one of these little distances is 3 units, and that's my standard deviation. So a couple of questions I want to ask you here. Nearly all of the girls' heights are between which 2 values? So if you go back up to our note right here, one special characteristic is that nearly all of the data will fall within 3 standard deviations of the mean. That's either direction. So nearly all girls' heights is basically this total distance here. So it would fall between 56 inches and 74 inches. That's what that's telling me. Nearly all the girls' heights will be in this range. You can also figure out your range from there. Your approximate range would be 74 minus 56. 18 inches. So that's your approximate range as well. The taller 50% or the taller half of the girls are taller than what value? So now what you need to know there is the mean cuts the graph into 50% on each side. So the taller 50% are all taller than 65 inches. We can do the same thing for the boys' heights. This time the boys' heights have a mean of 68 inches and a standard deviation of 2. So each one of these little tick marks needs to be 2 inches away from the one next to it, like a number line. What is the approximate range of the boys' heights? So what this graph is telling me is that pretty much all boys are going to have heights between 62 inches and 74 inches. That would make a range, if we subtract 74 minus 62, of 12 inches. And the shorter 50% or the shorter half are all shorter than what value? And that's that center, cuts the graph right into the 2 halves, and the shorter half, they're all shorter than 68 inches. The shorter half. And that's just a quick introduction to the normal model. There's a little bit more that goes with the normal model, and we'll discuss that in more detail in the next day of notes.